All right. We have a special kind of structure called difference of squares. Okay, and the reason that this special structure is called difference of squares is just because what the problem looks like when it's written out. So let's just remember always that multiplying and factoring are opposites. So I'm just going to put an example of multiplying here again because I want us to never forget that, right? Because the more that we hold on to that, the more this isn't going to feel like a new thing, but just kind of a growth of what we already know. So let's just do this multiplication problem, for example. And what I want you to observe is that it has a very specific structure, which is this term and this term are the same, this term and this term are the same, one is positive, one is negative. So when we multiply 5x times x, that's 25x squared. 5x times negative 7, that's negative 35x. And 7 times 5x, that's positive 35x. And then 7 times negative 7, that's negative 49. So to point out, like this times this and this times this are going to be the same because it's the same numbers, right? 5x and negative 7. 5x and 7, but the only difference is going to be the sign because this one's going to be a positive 7 and this one's going to be a negative 7. And so look what is going to happen. This is negative 35 plus 35. That's the same as 35 minus 35. That is 0. And so when I'm done multiplying, my answer is going to look like this. And look what it's going to be. It's going to be a difference means subtract, of squares. What does that mean, squares? Well, you know what? This is the square of 5x, right? Look, this is 5x squared. That's what this is, right? And this is 7 squared, right? So this is 2 squares being subtracted, all right? So now, if I see something like this, if I see something that's a difference of squares, right, then I'm going to say, oh, okay, well, I know that when I factor this, right, when I factor this, what's going to end up happening is just like this. I'm going to have one positive and one negative, and it doesn't matter the order, okay? And this are going to be the same, and you know what they're going to be? It's going to be the number that I would have to square to get this. And this number and this number are going to be the same, and it's going to be whatever number I would have to square to get this, okay? So what number would I have to square? What number would I have to multiply by itself? Look, here it was 5x times 5x, that's 5x squared, right? 5x times itself was 25x squared. What number would I have to multiply by itself to get 16x squared? Well, let's see. And when you look at your multiplication chart, and I don't have one, but if you look at your multiplication chart and you go to 16, you'll see right on that diagonal line that 16 is 4 times 4, right? And then to get that x squared, it would be, right, this would be the same as 4x squared. So what I'm going to do is I'm going to put 4x and 4x, okay? And here's the thing, right? That makes sense because when I multiply 4x times 4x, that's where the 16x squared is going to come from. And then what number would I have to square to get 81? Well, again, you can look at your multiplication chart along the diagonal, and you'll see that 9 times 9 is 81. So I'm going to put minus 9 and plus 9, right? And so this is the answer if I factor this, okay? And the reason is 4x times 4x will be 16x squared. But then look, I'll get plus 36x minus 36x. Those two will just subtract to be 0. And then negative 9 times positive 9 will be negative 81. And I'm done. Okay, so when you see something like this, difference of squares, you're just asking yourself, what has to be squared to get this? What has to be squared to get this? And then you just set up, look, 4x and 9, those are going to be my two terms, right? And the format is like this, okay? And it's a very specific format that works in a lot of different situations.